Welcome. I am Luke Costlow, and I have a business called Gribley Permaculture, and this is what we are going to talk about. And so, just so we have the game plan for the next 90 minutes is, first what we're going to do is we're going to just make sure everybody has like a pretty functional understanding of permaculture and how the framework works, and how it's kind of universal. And we're going to look at these problems, and we're going to use permaculture to look at those problems. And we're going to focus on these three main things that happened in Helene. Depending on where you are, you might have had one or all three. And then we're going to start talking about some of these holistic strategies I think that we can use to hasten the regeneration and stabilization of the ecosystem. And so I will say that I move pretty fast and I talk pretty fast, and you're not going to be able to write down every single thing that I say. And I don't want you to either, because I really want you to get the big holistic picture of the concepts. And we can dive in deeper into any of these things, but we're kind of trying to see the forest, not the trees, today in this. And just sign up for my email list and I'll send you the slides and you can have them to peruse later. And I will lose my train of thought if we have questions. Well, this is a pretty small group, so I guess there's questions, we'll see. But if you can, try to save them for the end, and hopefully we'll have some time, or email me later. But I just want to make sure we get through all the slides that I have. So that's it. So let me tell you a little bit about me. I grew up in West Virginia and Indiana, half of my growing up in each, and we lived in the suburbs. We had a yard, we mowed it, we never grew anything. My parents put lava rocks down underneath the bushes. So we didn't know anything about anything. You shouldn't do that. Then I hiked the Appalachian Trail in 2012, and I met my wife, Megan, who's actually here today. Hey. And the Gribley, where that comes from, that's my trail name. Gribley is the character from a book called My Side of the Mountain. It's a book written in 1963 by Jean Craighead George, about a little boy who runs away from home in New York City, and he goes and lives in the Catskill Mountains, and he trains a falcon to hunt for him, and he hollows out the bottom of a hemlock tree, and he lives in there. And he was he walked away from home. He didn't get stranded in the wilderness. He went to the wilderness to live within it as a part of the ecosystem. And that is was hugely impactful to me, that you could, even in fiction, have the dream to be able to go and do that. And so I fell in love with ecosystems. And not just plants, but ecosystems, the system of it all, right? And then I read Animal Vegetable Miracle, which you haven't read that yet, Barbara Kingsolver's memoir about spending a year growing their own food and living on their farm and connecting with the land. And that really opened my eyes to a lot of how our food gets made and how disconnected we are from it. And then after the trail, I moved to West Asheville, and we started gardening for the first time. I came to the conference for the first time, and we were just renting land, and that's what we did. And I started putting those two things together, the ecosystem and the gardening, and I realizing that my garden wasn't really part of this greater ecosystem. And so I was oh, I have a genius new idea. Could we garden like an ecosystem? And then I found out that was not my new idea. That was permaculture, and permaculture wasn't even a new idea. That is ancient indigenous, how people have been living as human beings on the planet since we've been human beings, right? And so that set me off on my permaculture journey. And then I bought my house, and I was great, permaculture time. And I wanted to implement permaculture, but where do I even get started? And so I tried to hire people. I was somebody come to my house, permaculture me. And I couldn't find that. And so then I guess I realized I had to figure it out for myself. So I had to go figure it out for myself. Then I went and took a permaculture design certification, which, has anybody here done a PDC? Cool. Permaculture design certification, mine was there are lots of different types, but mine was a 10-day intensive at Wild Abundance, which I highly recommend involving yourself with Wild Abundance in any capacity that you can. And then I started doing design plans, and I was offering those to clients, but then I make a design plan, I hand it to you, and I say, here you go. And then there's just too much for the person to then just go implement. No matter how much time I spent explaining every little detail, they weren't part of the process of the framework and the thinking of figuring it all out. So now I'm doing permaculture coaching. So if you're interested in coaching, there's flyers, and essentially it's a one-on-one coaching thing where I'll teach you everything you know about permaculture and permaculture design using your land as the classroom. So that's me. Let's get started. with this first. And this is what we started with. This is how my PDC started. This is the first question. We all got together, we broke the ice, and then they got a chalkboard out and they said, okay, everybody, what problems and threats to the planet, or what are the things that keep you up at night? So just anybody popcorn to raise your hand. What are some things that like stress you out so much? Go ahead.
I mean, not exactly permaculture, but just giant trash heaps.
Giant trash heaps, totally. It's like the Pacific garbage patch.
Yeah, just
blows my mind. Yeah, that's awful. We gotta fix that. Anything else?
Microplastics.
Yeah. Microplastics everywhere. No, blood. Ugh. What else?
Deforestation.
What else?
Overconsumption.
Overconsumption.
The kind of world that my young children will inherit.
Yeah. It's not just today. It's only getting worse. Yeah, so we could do this all day, right? And we did. You know, we really just kept going and going and going. And it was an exercise of like identifying problems. But here's the thing, right? Right? Like all of these things are things that are happening, and it's terrifying. And I found that permaculture gives me like this like little nugget of hope, like deep down, that like we can live on this planet and with one another in a way that not only is just like that is sustainable, but in a way that's like really actually regenerative, that builds life and builds abundance and fertility. And so take any of these things, and I would say that the first place I would start would be applying the permaculture framework to figuring out ways that we could address these things. And so the same way, you know, we can apply that to Helene. Welcome, come on in. So yeah, in a nutshell, if we start talking about permaculture, this is what I like to do to like explain permaculture. So, you know, this guy over here is permaculture, and he's like in the sun, and he's got his backpack with the water bottle and his sunglasses and his hat and everything, and like it's adaptable, it's sustainable, like he's ready for business no matter what happens. And this guy, like he's got all the pieces, but he's not using them correctly. You see how he's like got his hat on backwards, but he's like still using his hand like this, right? So I think it's like a lot of times when I'm meeting with people, and you know, that I feel like a lot of people are thinking like this, and I want people to be thinking like that. And why I think that it's so useful and versatile and applicable in so many ways is for these reasons, among others, that it's scalable. And it's scalable because it's just, permaculture is a way of understanding like how the universe is oriented and how we can then engage with that. And those laws of the universe are true at the, you know, atomic level. Electrons orbit an atom according to the same laws that, you know, galaxies orbit in space. So that's really hopeful. And then that it's holistic. None of these things exist separately. They all exist together. And if we have a container to understand, sometimes it's really hard to look at a holistic thing when there's so much. But permaculture gives us a framework to look at the whole picture all the time. And I love that it's problem solving, but it's problem solving based on observation. So one of the key skills in permaculture is to be able to identify problems, solutions, opportunities through observation. And that it's adaptable. Permaculture, the framework of it, now maybe the way it's applied in Appalachia is different than the way that it's applied in Florida, is different than the way it's applied in Australia, but this system, the framework, is adaptable to any place on planet Earth, and that is permanent. And so we never just, if there's insects on my plant, I don't just spray them, great, insects are gone. I want to always go back and look for what the problem is, the root is, and then make a permanent solution to how we do that for the better. So that's great, but like, what is it? You know, I still haven't defined it for you yet. And so Bill Mollison and David Holmgren are these like kind of like the the OG founding fathers of permaculture back in Australia in the 70s. And at this point in the presentation, it's always important to say that, like, again, they didn't invent this way of growing and living in an ecosystem. They took what indigenous people have been doing in different places all over the world since we've, been human beings, and have packaged it in this way that I think is really effective for teaching and sharing and communicating in the way that permaculture almost even like a language that you can learn to speak. So they say it's a design system for creating sustainable human environments, mimicking natural ecosystems, provide food, energy, shelter, and other needs in a sustainable way, emphasizing ecological, economic, and social sustainability. And I agree with that very much. And I would just add to that it's permaculture is the intentional design of that ecosystem that centers the human steward and utilizes the creativity and agency of people to create a mutually beneficial, abundant, self-sustaining, regenerative, living, biodiverse community of functional plants. So where that all comes from, the basics of permaculture is we start with these three foundational ethics. And those ethics are care for the earth, care for humanity, and a fair share for all. And in the center where all those meet up, that's permaculture. So you know permaculture is happening when care for the earth, care for humanity, and a fair share for all, including the people and the animals and the plants, and everybody has a fair share in that thing. And then it's also, I think, really interesting that when you combine two of these things in the Venn diagram, in a section like this here, where the yellow meets the red. So care for the earth and a fair share, that's resource stewardship. That's helpful of you to think in like that section. And when you care for humanity and you care for planet Earth, that's where these regenerative systems come from. Them, we can nurture this abundance out of the earth not just without hurting the earth, but with actively helping. And then again, care for humanity and a fair share. That's where all the social components of permaculture come from. So this whole thing, all put together, is the foundational, root core of permaculture. And from these ethics, we develop these principles, and these are the 12 principles that I use, and there's more we'll see, but these are where permaculture happens. These are where, when a decision is being made about where do I put the fence, do I put the fence, whatever the problem-solving, decision-making, planning that you're doing in your garden, the more of these that are part of whatever decision that you're making, that's permaculture, So if something, or if something is directly against one of these things, right? So like use and value diversity. In permaculture, I'd never say go plant an entire field of corn, right? A monoculture of corn. And so whenever things are using these, that tends to be a permaculture. That is how permaculture is made manifest. And when things are not applying these principles, then we need to apply self-regulation and accept feedback and move on. So that's what I have here on your card in the back of this, so you can always remember it. And I will, throughout this presentation, I say, what permaculture principle is this or that, and we'll talk about it. So it always comes back to these principles. We're always talking about these principles. And if you're coaching client with me, you'll get tired of hearing me ask you, are you capturing and storing energy with that, or whatever? So, and then also, permaculture is not there is no governing society board of directors of the International Permaculture Certification Group or something. It's this anarchic, decentralized idea, and so those principles are some, but other people use others. So my teacher, Natalie Bogwalker, she includes 10 more in her teaching, and I think they're good. I pulled a few here. They use appropriate technology, not too much, not too little, and using the right material in the right place. So what we build our houses out of here is different from what people build their houses somewhere else. And the idea of redundancy. If you have I know some people who have a pond and there's two drains and the one drain didn't work, and so luckily there was another drain, even though it caused some problems. But there needs to be multiple ways for the water to get out, multiple ways for stuff to happen. So I have one, Esse Quam Videri. It's the state motto of North Carolina, which I actually got tattooed on my arm before I moved here. So I was just didn't even know that when I got it. So I was meant to be here. But that means essence rather than appearance. It means to be rather than to seem, right? The difference between being and seeming. And so I always like to make that distinction where just because somebody's garden, don't try to make your garden look like a perfect, beautiful garden. Make your garden an actually functioning ecosystem, And there's no way to fake that. Or you can look like that on Instagram or whatever. But we always are really trying to make it really be right, okay? And so when we start to, make decisions and we're using these principles and these ethics and we're thinking through these things, then we start coming up with these like strategies. You've heard people talk about berms and swales and, integrating these kind of things and food forests and yada yada. These things come from those principles. And those principles, you can see, you can imagine, a gray water system, where all the waste management stuff, waste reduction, right? So one of the principles is produce no waste, but that's where, you get it. That's where these things come from. So that's when you're thinking about people doing permaculture, this is what you're thinking of them doing, right? And that's how you get to that point. Okay, so all the things that were bad on Earth that we were talking about before, let's do that same exercise again. But let's focus on specifically who is here is everybody here during Helene and Helene affected stuff? What kind of problems, what are we dealing with now? What is the aftermath that we are dealing with now? Anybody? What are the things you see most? Sure.
Unhoused communities.
Yeah, definitely. Yeah.
Road washout.
Roads,
Loss of forests and so many trees down.
forests, trees, ecosystems, habitat. Yeah. Trash in the trees. It breaks my heart. How are we going to get all this plastic out of trees 15 feet, 20 feet up in the air? Yeah.
Toxicity.
Huh?
There's some toxicity.
Yeah, toxicity. There's a lot, and I don't want to see any more pictures of Helene carnage. So I'm not gonna have any in the slideshow. I have a couple pictures of landslides at my house, but I'm not gonna show you because we all have seen enough of that. So yeah, this is just a short list of some of the things that we're dealing with, right? And we need to figure out problems to these, and I think that permaculture again is going to be an answer, a component at least, to fixing many of these things. Okay, so that's what we're here to do, and let's just look at some of these facts, right? What the fact happened, and some of this stuff, 140 miles an hour, and then by the time it got to us, 80 miles an hour. French rod, 23 feet, so, 3 times flood stage. I'm an apple, I love apples. Flooding wiped out 70% of local apple orchards. It's bad, it really is, it is bad. And we have got to fix this stuff. And I think a lot of us moved here or live here because the ecology and the environment here is so vibrant and abundant, and that I just want to get this stuff fixed as quickly as possible. So what do we do, right? That's why we're all here. What do we do? And we do what nature would do. We just help that happen faster. That's my answer. And that's the same way that we garden, in permaculture, that we do the same thing that a forest does. We just bring that into our zone of control, right? So, like I said, we're going to focus on these 3 things. And though there are many, but I think that even people with just a little bit of land or no land, we can be addressing a lot of these kind of things. Both how can we prevent them from happening in the future, or lessening the impact that they have in the future, and then actively repairing some of these things. So yeah, we're gonna start with fallen trees. I guess I can take a quick question real quick if anybody, are very good? All right, cool. So let's just talk a little bit about tree biology stuff real quick, because I feel like a lot of people don't know this, and that a healthy tree is going to be a more resilient tree. A healthy person is going to be more resilient to a cold. A healthy tree is going to be more resilient to a storm. And I have some examples here, and we'll just go through them real quick about just things that you can see. And if you see these in your trees or your yard, or these are practices that you or your neighbors are doing, just think about it. The first one here is you see how this tree looks like it's like a telephone pole growing out of the ground? That's not that's not how a healthy tree grows. This tree is not healthy, but there's a root. You see the root flare that comes out right there? That's a tree that has these buttress roots. And if you plant it too deep, that's what you get. And then if you were to dig that soil back, what you'll start to see is this root girdling. The tree will grow roots above the roots where it's supposed to, and it'll go around the tree, and it'll strangle that tree the same way that bittersweet would. Likewise, if you don't take off the packaging, like ball and burlap packaging on trees, people are like, oh, just put it in, just burlap, it'll decompose. The roots will circle like this and grow and be pot bound, and that'll kill a tree. Or if you put like a ring around, if people put like a little edging ring around the tree, if it's that small, that'll kill a tree too. And then what else? Volcano mulch like this. Mentor of mine always says 2 or 3 inches is mulch, 2 or 3 feet is a compost pile. And if you're getting that much mulch on a thing, that girdling will also happen in there. Not to mention the decomposition of the bark, and then also just the heat of the inside of that compost pile can kill a tree. So don't do that to trees. And trees don't grow in lawns. The trees grow in a forest. They grow in a community of plants, not lawns. Be careful with hardscaping around trees. That damages the roots. I mean, you get the point here. Vines, if your trees aren't healthy, they're going to be more susceptible to damage and therefore more likely to fall. So deal with these tree issues while you can. And then if we were to zoom out from just individual trees and look at the forest as a whole, a lot of our forests around here look like this, and that looks like a healthy forest. But if you look, those trees are all kind of the same age, they're all the same size, that canopy is completely closed, there's no sunlight penetrating, the forest floor has nothing growing on it, and so this whole, what should be a vibrant, layered polyculture community of plants in a forest is instead just kind of like a monoculture of these trees all the same age with nothing underneath. And that's not a healthy way for trees to be. Or this is like a white pine forest, kind of same kind of thing. A healthy forest looks like this. Sunlight, trees at different ages. This one is huge and it's shading, but there's still room and space for all these different individuals to live, as well as all this ground cover and all that kind of stuff, right? And then if we're looking over here at these trees, a lot of forests do look like that. Mine does, because this is what happened. And this is what happened all over the region in a lot of places. They come and they clear cut the trees, and then as the trees regrow, they regrow at the same speed and time, and then they eventually just become, like that, or those pictures over there. But what we want to be doing if we're managing a woodland and making our trees healthier is that we want to take out some and leave these ones so that these ones can grow. And now we have a diversity of age. And if we look at our permaculture principles, one of them is to use and value diversity. So always, the more we can be diversifying anything, that's a good thing too. So having a diversity of age, size, species, etc. in our forest. So if your forest looks like that, start trying to make it look like this. And then some nerd stuff. Let's just talk about photosynthesis real quick, because it blows my mind about how amazing this is. And so this is what happens in a leaf. So now we're in the chloroplast of a cell. So that's an organelle within the plant cell, the chloroplast, where photosynthesis happens. And a photon, a particle of light from nuclear fusion in the sun, comes shooting out and travels through space at the speed of light for 8 minutes, enters our atmosphere, and then hits this, like they call it the antenna pigment, in a chloroplast. And then that knocks the electron to here, and that knocks the electron to here. That's called the electron transfer chain. And then the electron goes to there, and that's the beginning of the photosynthetic cycle. And so what happens is using a photon, like light, a light particle, and water, and from the ground, and CO2 from the air. If you remember your high school chemistry, when those things all crash together, it produces these hydrocarbons that those are like the building blocks of all organic life, like carbon-based life form. They take the hydrogen and the carbon, and what gets shut off, both of those, you lose this oxygen and you lose this oxygen to make those hydrocarbons, and that's where we get the oxygen that we breathe, right? So literally plants are taking sunlight and an electron moving it all along this chain, fueling this whole system, breaking apart water molecules, breaking apart CO2 molecules out of the atmosphere, and then releasing oxygen as a byproduct and the hydrocarbons with which it builds its structures. So what makes it, which is just so amazing to me, is that when we take a log from a tree and we put it into our fireplace and we add heat to it, what's the other thing, what's the chemical that's needed for combustion? Do you remember? Oxygen. And so what we're doing when we provide oxygen back to that plant, to that log, is that we're reuniting the oxygen with the hydrocarbons, and then what comes out is the heat of the sun. Like, it's literally captured solar energy that we just go back in the chemistry and remake. So it's sunlight made physical, and that power is always in it, is what I'm trying to say. And so that power is what we're going to get out of it as we try to decompose these trees and build soil. And so yeah, there's all this in the tree as well. And when I see people hauling trees away from a place that they were cut down, it breaks my heart, because those things need to be in that place. And we don't need to just concentrate them all down into like the stump dump or whatever. Because that's not what nature does. And in permaculture, we're always trying to mimic the way that nature operates, because we are nature operating within nature, and we should follow those rules. And so what happens is the animals start to break it down. They break it down mechanically. You know, beetles are chewing it up and turning carbon into nitrogen. And then their bodies become energy that then other things can eat. The woodpeckers mechanically tear it apart. The bears mechanically tear it apart. The fungus and the mycelium move through. There's habitat inside. And there's this whole ecosystem that exists just within one log. And so those logs, whenever a forest without fallen logs on the ground is not a forest. We're missing important components of that forest. So what do we do with all these dang trees? Because they're everywhere. And so here are some of the strategies that we're gonna talk about. First of them is, I call it brush on contour. This is a topographic map. Does anybody not know how to read a topographic map? I'm explaining more or less. These, if this doesn't make sense, I'll go deeper. These brown lines, if you were to stand on that brown line, and they don't really exist in space, but if you followed that line, you would be walking on a flat surface. And if you cross these contour lines going this way, you're going up 10 feet in elevation every time you cross one of these. So the closer those are together, the steeper the hill, the further apart, the more shallow the hill, right? So when you look at a map like this, and this is my house, this is my in-laws own this house, I own this house, this is our neighbors, and so I kind of manage both of these parcels. And you can see where the stream runs down right here. I see all those contour lines kind of curve, and that's just like when you're out hiking and you come to that place you're walking on the side of the trail. It's pretty much level, right? You're like coming around the contour, and then there's that place where the water comes down, and then there's like a little bridge sometimes, and you kind of go right back the way you came, around the bend. You go around the bend like that. So that's what that is, a stream coming down through a cove like that. Does that make sense? Everybody reading this map? 3 dimensions showed in 2 dimensions. And so when I have a tree that's down, first of all, I don't want to haul, the tree falls down here, I don't want to like drag it up the hill or drag it down the hill, try to get it out of there. But I want it to decompose as quickly as possible. And so what you do is you just pile it up on contour like this. Cut it up real fine, and this one's real nice, the way that set kind of the post and stuck in there. And look how much habitat is in here. Think about how much water, what a giant sponge this thing is right here. And it's full of insects, and it's a huge important part of the habitat. Or if you have a situation like this, on this hard clay soil, nothing can get purchased, well, you start putting logs across that hill. You see like where I'm standing down the bottom of the hill, and up there is the top of the hill. Even just putting those logs like that year after year will slow the water and force it into the ground. It'll create a shady spot on the back of that area and hold moisture longer, and it'll slow it down mechanically. And then, this is the kind of thing too that's in the woods everywhere that around my house, is just cut it up and put it on contour, and it will slow the water. But I do want to say, sometimes they're like, great, permaculture guy told me to put my brush in a pile in the woods, and then they'll just do a giant brush pile like this. And that's not what I'm saying. I'm not saying build a giant, taller than you pile of firewood. I want it to be distributed long, low things, because the goal is to keep it all as close to the ground as possible so that it'll stay wet. And likewise, if you just have a bunch of trees laying all jackstrawed in the woods, and there's air that's able to flow underneath of them, water will flow down the hill, they'll dry out and become a fire hazard. And so, like, if nothing else, just get all that wood just onto the ground as much as you can. Get it up out of the trees and get it onto the ground as much as you can. And then use it where it is. Don't spend all your energy and time hauling it off. Like, if you can incorporate it into the place where it is, that's the ideal scenario. So it's hard to see in this picture, but this is a tree at my house, and the tree grew, poplar tree, and then there was a branch here, and then another branch, another branch. It was kind of like, like 3 branches, kind of like this on the end. And then this one just went and just sheared off. There's this giant wound. So that part's still standing, but not for long. I'm gonna take it out. But anyway, so it came crashing down through the garden like this, and I've got it cut, and it's right through the middle of the garden, not on contour. But we moved it, and we had an excavator on site, so that was helpful. But you don't necessarily have to use an excavator to do this. You could also just cut it up smaller and move it. But that 24-inch in diameter log has become this like retaining wall to hold this terrace that I've backfilled against. And as that decomposes, it's going to be like a giant sponge. If you ever picked up a log out in the woods and it's full of spongy stuff. So that'll be capturing water. It's right where it was, and it got done without having to use a lot of other stuff, right? Likewise, like I built these steps out of a tree. It wasn't going to split it and haul it all out of there. But it can become steps, or it can become, you can cut, wood cookies out of it to make, wood cookie, like a 6-inch thick cross section of the tree, make steps or pathways or all kinds of stuff. So use it where it is. And then another thing about trees that I'm always thinking about is, if you have organic material of any kind, always, if you live on slopes, I always say to try to maintain or increase the elevation. There's potential energy. You got a car sitting on top of a ramp, it has potential energy, and then when it starts going, it has kinetic energy, right? Potential energy is energy captured and stored that you can use later when you need to. And using our elevation in this region is a good way to capture and store energy. And we're the only animal that I know that can actually build mountains, by building up the soil intentionally. So if you have vehicle access to the top of your site, like try to get your stuff up the site and not down if possible when you're thinking about those decisions. As I see trucks, landscape trucks, just like coming down the hill all the time with like sticks and wood chips and stuff in the back of the truck, and then I'm always like collecting stuff from like clients and stuff down the hill and driving it up the hill. So like you can always tell it's me, because I'm the one driving sticks and waste up the hill, but everyone else is driving it down. So yeah, bring the soil up when you can. And then, because here's why, right? So you can see this, that's Florida. That's the Florida Peninsula there, right? And this is the Gulf of Mexico. And this was like 2 days before Helene, like ocean water. And then this was like 3 or 4 days after Helene. And all that cloudy blue turquoise stuff there, that's our soil. That's the mountains that worked its way out the watershed and into the Gulf. And that's just the stuff on this side of the continental divide, not the stuff that all went to the Atlantic, right? So we need to keep our soil on the mountains. That's a problem. And so do that. Keep your soil up high. Biochar, there's classes here. You might take the biochar class yesterday or today. There's these guys, Alex Gray's in that green hat, and some other guys, they have a community. You can rent this and bring it to your house, and had them come down to Hendersonville to do the class too. But biochar, what it is it's wood that has been burned without, it's been charred, but it's been heated, but not combusted. No oxygen got to it. When you're burning it like this in here, that flame consumes so much oxygen at the surface in that open top of that thing that the wood beneath it cannot, there's no oxygen to get there, right? So it becomes this charcoal, right? It's carbonized without combusting. And if you look at this under a microscope, this is what it looks like microscopically. And in all those little pores, it holds water, it holds the soil microbiome. That's a great habitat for the soil microbiome. Biochar is a permanent soil amendment. It makes your soil better forever because it has this capacity to hold whatever nutrients are in the soil. The soil doesn't leave. So this is a fantastic way to turn wood, especially like the sticky bits that's not like logs and stuff, into biochar. So you can get this with your neighbors. There's other ways to make it. This is like a smaller version that you can make it. Same principle applies, that the fire can't go, and you can make biochar. So that's definitely something to consider. And then also, when the trees come down, there's going to be new microclimates everywhere. There's going to be way more sun, and that's a good thing because in this region, if we look back at the history of the region, like ecologically, 500 years ago, 800 years ago, there were mountain bison that lived here. That was like the megafauna of the region. And the mountain bison are very similar to like the plains bison. They're just smaller and tougher and lived in the mountains. But they grazed on these oak savannas. And the same principle applies as any other grazing animal. The wolves would move them around, and the bison would drop the waste, and their hooves would trample it in, and so they would graze this area heavily and then move on to the next area. And so in an oak savanna, there is sunlight that penetrates to the forest floor, and there is a diverse ecology of plants that get mowed once, twice a year by either a human mower or an animal grazer. And so this is the ideal, not necessarily a closed canopy forest. And these two pictures here, that tree, that's the same tree before a prescribed burn and after a prescribed burn. So you hear about controlled burns, prescribed burns. Fire goes through there, burns off all this leaf duff, kills all these little saplings. The big guys, that fire moves through pretty quickly. It kills the little ones, not the big ones, and it opens up the space for this to happen. I think that this is going to be a good strategy as we move forward, especially in places that there's a lot more sun. John and Claire talking to y'all. Yeah. And this is the difference between a natural meadow savanna fire versus a totally out of control, total destruction canopy fire. And that happens because this doesn't happen. That all that fuel, all those trees builds up and they can climb up and to get into the trees. And so it's scary, and it's not something that I'm not, again, permaculture guy is not saying go light your forest on fire right now. But I am saying that fire is part of the ecology of this place, and we would be wise to learn to use it as a friend and do that for our ecology. In North Carolina, I just signed up for the NC Prescribed Burner Certification course. I didn't get in last year, but I hope I did this year. And there's like a law, the prescribed burning law, and it's all these rules. And North Carolina is like really trying to this is like a thing the Forest Service is doing. And there's guys in their yellow shirts and all that, and they're walking around with these drip torches. And just a couple of little things, like they've cleared this whole area, right? So this is the fire break. So there's nothing burnable in that area. And the wind in this picture is blowing this way, right? See this picture here? And see how there's all these leaves, and this is where all the combustible material is, and obviously the wind is blowing this way. And so what the fire is blowing onto is just already burned bare ground. And then just a little bit at a time, it's just moving forward across that. And so it can be done in really, really safe ways. It's all about planning and paying attention to the wind and that sort of thing. But this is going to be part of the recovery. Also, I know Craig, I know we were talking about woodland forests and stuff. This might be a strategy that to get that forest into a place of that old growth kind of way. That's how stuff happens faster. And then if you have woods of any kind and you haven't been managing them in any way, really, you should be, because forests are interacted with. Animals eat the branches and they cut them and they move through them. That's not a black bear, that's me. And when I first bought my house, You can see like every single one of these trees is covered in vines. Everything green that you see growing there, no, that's not ginseng and golden seal. That is multiflora rose. All of it. All of it. All of it. And the people who had the house before me, they never cut a thing. They never went into the woods. They never cut a vine. And year after year after year, it got worse and worse and worse. So I mean, first thing is like do deal with your invasive species, but then feel empowered to like interact and deal with your forest. The NC Forest Service offers this service it's called the North Carolina's Forest Development Program. They will come and develop a forest management plan for you. I think on the website it says it costs like $100. I've emailed them twice and I've not heard a word from them, so I don't know if it actually exists, but there are also other private companies and things that will, a lot of arborists will also offer a forest management plan. I suggest that if you have a significant amount of forest. Eco-foresters are coming to my house in a couple weeks. They're a not-for-profit Asheville company organization that they'll come out and give you an inventory and talk to you. And I was hoping they'd come before this so I could tell you about it, but they haven't come yet. So follow up and I'll tell you, but I think you should look into that. Forest plan. And then I got a buddy, Paul Gay, who lives in Madison County, and he is a great tree feller. So if you got climbers and stuff too, so if you need like tree people who aren't just like, yeah, I'll cut them all down for you, and they actually care what's going on, let me know. I'll get you Paul's number. And then just remember, like in a forest, this is like a diagram of a food forest, but this is what a forest looks like. It has layers. There's the canopy trees. There's the middle, like an understory layer. So this is your oaks and your hickories and your those big trees like that. And then this is your sourwoods and your sassafrasses and your dogwoods. And then you have this like shrubby layer, and that's your flame azaleas and your rhododendrons and your mountain laurels and that sort of thing. And then you have these herbaceous plants, and that's your ferns and your grasses and all that. You have these deeply rooted plants where most of their action's happening under the ground. You have your ground cover that stays and spreads, right? And so in your forest, if you're missing any of these components, work to make your forest more along the lines of that. And then when we're talking about pastures, so let's say you have a big grassy pasture, there's a lot of it, right, in this region, lots of old farms and pastures, especially up here in Madison County. The same thing, right? So these are elk, and they graze this area heavily. All those elk eat that whole, and they deposit nitrogen heavily in that area. And then once the wolves realize that that's where they are, they run them off to the next thing, and then the grass is able to grow back, right? So if that doesn't happen, like these cows, they overgraze this area and they keep coming back and they keep coming back and they keep coming back, and eventually the grass doesn't have enough chance to photosynthesize enough to like put on enough energy to make long-term roots like this. So this isn't a giant carrot this guy's holding. They've dug into the soil 6 feet down with an excavator, and he's standing down in the subsoil, and the plant that he's holding here, the leaves are this big and the root is this big. And so that kind of root, that can withstand being grazed. And this kind of root over here on this plant that's not managed that way cannot. So again, if we're managing grasslands and you're just mowing them, let's think about other solutions. And maybe you don't have room for a herd of cow or elk on your land. Justin Rhodes is a little guy, and doesn't mean chicken tractor, you've heard of that, but I like this design a lot that Justin Rhodes makes. It's called the Chickshaw. And it's a box with a lid and a ramp for the chickens here, and that ramp closes up as the door. And then there's like little roosting bars here, and the bottom is just poultry cloth, so the droppings drop through, and it's on these wheels. And then where you can't see over here is just a handle, and you can pick it up and roll it around, right? So instead of a wolf chasing your elk around, you are just moving your chickens from place to place to place. And so you move them into a place like this, let them do what they're going to do, and when this starts to get degraded, then you move them to a new pasture and let your pasture come back up to that. And also fire is a part of grassland ecosystems too. And again, this is a great example. You can see how, like, if you lit the fire over here, you can imagine how fast it would spread across that. But since the wind is blowing, the fire onto that already burned area, that line just kind of slowly moves its way across. And so that's how fire would happen. And so this is contour lines. They're upstairs. Thomas Leonard is one of the board members. He's the director of Contour Lines USA, and they have a great thing where they'll come out to your land and you rent the excavator and you prep the land, and he'll come out and show you how to run it and then help you lay this out and set it up. And so these are berms and swales on contour. Anybody not know what berms and swales are? Berms and swales are, so I can't figure out which way this hill is going actually from this picture, but let's just say that that's the high point and this is the low point. So what you would do is this line is flat, it's level all the way across this brown line. And that brown line is you came through with an excavator and you dug out the dirt and then you pile it on the downhill side. So if this table and this was flat, let's say I take out this earth with excavator and I pile it up, and here's the table, and this table goes all the way across the room, and when the water flows down from here, instead of it just going across the table, instead it gets stuck down here and then has to penetrate the ground into the berm and then into the ground below it. And then you can plant your trees. So Thomas and them in Contour Lines, they plant a tree. So there's hundreds of trees, planted pretty close together, and they'll thin them out as they grow in these berms all around that. So when it rains, those fill up with water. It doesn't dry, there's no erosion, it stays in there, and it sequesters a lot of water. So if you have a pasture and you don't want to, you're just going to mow it, reforest it permanently with this system. Because look at this, if I was the egg of a parasitic wasp that I want to have in my garden, I live here. That's the habitat for those overwintering eggs. That's the habitat for birds. That's the habitat for snakes. The ecosystem lives in that, because for millions and millions and millions of years, every winter, that's what a grassland looks like. But if we clean it up like this, there's no ecosystem here anymore, right? So we got to have all these things: the deeply rooted grasses mixed with the perennials, the flowers and that kind of thing, and then coppice trees, we'll talk to you about in a second, and then also the animal interaction. So pastures require grazing. You have to have animals if you're going to have a pasture, or you have to be that animal in some way. Mowing is that, but there's also other things that animals do that you have to do. But what I'm talking about coppicing is, you all have seen this happen before. You cut a tree, or you're driving along and you see somebody cuts the top out of all their trees, and then stumps, and the stumps put off like a ton of sticks like this, right? And that's called coppicing. And certain trees love to do that: willow, locust, maples, poplars. Certain trees, this will kill it. An oak tree or hickory tree, that'll kill it. But when you do this, what's really cool is in cultures, especially in Europe, but cultures all over the world practice this, where you don't have big mature trees to heat your house or to build with, or to use wood as a building material and tool handles and stuff. You don't have a whole hickory tree to make a hickory handle. You can do this, and especially if you're like a feudal peasant or something, right? The king's trees are the big oak trees, but this is what you get. And so, this is I think this is going to be a really important technique for as we are growing, because you can stack in space. So stack and pack is like a permaculture kind of strategy that you want to really get as much density in as you can. And so you can grow a coppice tree like this, and then you can grow crops underneath of those that they don't occlude the sunlight. And this is great fodder for if you have sheep or goats or something like that. They can cut these off and eat it. When the pastures start to get fried in the late summertime, the trees, you can feed them the willow stuff. And it's really easy to manage this on a human scale. So I can come through and cut all these limbs off with a machete or a saw or a pair of pruners, and then you can just drop that right back on the ground. So you're building that soil back up. So even if I'm growing oak trees and I want to have this big forest, or if I was going to turn this into an oak forest, those oak trees they're like a secondary succession species. So they want to grow in the shade and the cool underneath of a forest of faster growing things like poplars until they get big enough and strong enough, and then they'll outcompete the poplars. But if I was trying to grow oaks in here as fast as possible, I would also plant these trees with them, and so a couple times a year I can come by, chop off all that biomass, and use that as a mulch as I am trying to grow my bigger trees. Does that make sense? So yeah, coppicing, and then pollarding is if instead of cutting the tree here, they cut it right here, and then that would be called pollarding, and that's what you do when you want to like keep like deer or if you had sheep underneath or whatever, that they can't reach up that high. Oh, also, like here we go around the mulberry bush. Mulberries are trees, but if you cut them like this, then you can have a mulberry bush. There's also like agricultural reasons to do it. It's easier to harvest from that than it is from a tree. Mushrooms. Mountain soils, where we are right now, our soils are fungal rich, very fungal rich for the decomposing wood. And so we want to do as much as possible, and one of the primary decomposers of wood is mushrooms. So here's some of my shiitake logs, put them on the ground. I'm stacking functions here as well. This is like a erosion. There's water that runs through there due to some stuff that needs to be fixed up above, but I put the logs there so they catch that water, slow it down, absorb it into the wood, make the shiitakes. This is good. This is a great sign. That's mycelium, so that's what you want to see when you're growing it. And then even things like with your wood chips. I was downstairs just talking to Olga with Mushroom Mountains, and there's this King Stropharia mushrooms. If you have a big pile of wood chips, she has a bag of that stuff, King Stropharia, and she's like, inoculate 1 yard of wood chips with that, and they'll grow like right in the wood chips in your pathways. And they'll have to just decompose the wood chips faster. So, and there's me with the wood chips in the pathways. So, mushrooms, if you're not growing them, make them. Another problem I see a lot is people get rid of the tree with the root ball still around. And it's not a problem ecologically, but they're kind of ugly and sad, and you want to deal with them. And so this picture isn't very good, but I've seen people have some really great success just getting a pressure washer out and just blasting all the dirt off of the roots so that you can get your chainsaw without like hitting dirt as you're cutting through roots. So you clean them up first, let them dry out, clean them up again, and then you can cut them down. But also, there's an opportunity in nature. This is what happens. They create these little like crater ponds, And so, if they create a little microclimate. So, like depending on how the tree fell, you're going to observe and interact. That's one of the things, right? Creatively use and adapt to change. That's another principle. So, something changed. This tree fell down. Well, now you've got this wall. Which way is that facing? If the north side is over where that tree is, now you have a windbreak from cold northern winds. That's going to be a bit of a warmer, ecosystem or microclimate here. Also, I'm in a microclimate. I'm feeling the air conditioner here. Yeah, maybe you can create a bit more of a wet environment. So if it's possible and you can, you do what nature would do again in this region with those. And then also, not all trees fall down. So what do we do with these trees that are still standing? And I would say, if they're not too dangerous, too close to the house or your trails or whatever, then I would say you leave them because they are really, really important habitat. This is the Wasselic poplar. Making you anything about Wasselic poplar? So we met this dead tree. But it's an amazing tree, and it was dead when we were there, but it's still, I don't know if it's still standing. I think it's still standing.
I don't know.
I don't either. But it is full of these kind of like nooks and niches, and it's a really important habitat. So if you can, keep them. And then like the book I was telling you, My Side of the Mountain, where my name Gribley comes from, he lived in a tree. I mean, it's fictional, but he lived in a tree like that. And there's lots of stories about people living in trees like that. Morgan was the first person to settle West Virginia, and they say he lived in a tree like that. And yeah, bears don't live in caves. This is the natural hibernation zone for bears, right? So these standing, dead, and dying trees are very important for an ecosystem. So just because it's dead doesn't mean get it out of the ecosystem, because that is really important habitat. Consider that as well. And then if you don't have chainsaw skills or you're afraid of chainsaws, I do think that we live in a rainforest. And I think that even basic sawing skills is important. This is from the Buncombe County Extension. I just pulled up. They had class, free and open to all, you know, tools provided. But then also keep your chainsaw handy. You know, after the hurricane, my kit was in the back of my truck for, you know, a month or two. I just took it everywhere I went, and whenever I go anywhere, I have all those things, because if you're gonna be cutting, A, you gotta be safe, but B, there's nothing worse than like not having your bar oil when you need it, like out in the field. So I keep it all in a kit, and then I have two kits. I give this is for cutting, and then this is for splitting. So like remember the steps I showed you? There were like trees split in half. The way that you do that is that you take, if this is the tree, I would take it's a metal wedge, and you just kind of get it right into the heartwood here on this side, and that'll open up a little crack right here, and then you just and then you put another one in here, and then that'll open up enough of a space that you pull out this wedge, and you leapfrog it, and you leapfrog it, and you leapfrog it. That's how you make like a split rail fence or cut stuff. So even if you're like out in the deep woods and you can't move a tree around, but you still want it to be long, you can split it and then move it by halves or by quarters if you need to, even huge, humongous trees. So it's a lot of work, but you don't have to have an excavator to move big trees, and you can cut them down, not just in big round, you know, logs, but you can split them. Okay, flooding, 30 minutes left. We're doing great, gang. So we all know Swananoa got hit pretty hard, and I think the reason for that is specifically because of the way that the Swananoa watershed happens. And so this is the reservoir that the big pipe in Nashville didn't have water for all that time. That's that reservoir. Up there is like Craggy Gardens and all that, and the Parkway. And then this is Swananoa River, running Mashville, Swananoa, Black Mountain, or I guess the other way. And welcome. And I just think that my point in even showing this is that like those of us who live up high, we have a moral responsibility to think about our neighbors down below. And the more we build houses and roads and driveways, and that water is just coming downhill, and the people up on the uphill say, well, not on my property anymore, it's their problem. That compounds and compounds and compounds and compounds. So as a person who lives at 2,800 feet, I think that that we are morally responsible for holding water up higher for our friends. So I just want to say that. And let's talk about water. Let's talk about water using math. Okay, yeah. So, is that how you feel?
Yeah, kind of.
It's okay. It's easy math. It's easy math. I promise. I want you to. I bring this to people all the time because it blows my mind about like. It's like hard to think about like how much water is an inch of rain. I don't know the inch of water, right? But like that inch over square footage can be a lot. So do a little bit of basic algebra, where X is rainfall in inches, and Y is the area that rainfall is landing on. Let's say a roof. Okay? And the formula that you want to remember is inches of rain times area of impact times 0.6 gallons per square foot. So in an inch of rain, you get 0.6 gallons from 1 square foot. Okay? And so let's say we have a 3-inch rain one summer afternoon onto a 12 by 12 foot shed that is 144 square feet. Everybody still following me? 12 times 12 is 144. So we have a 3-inch rain falling on 144 square feet, and we get 0.6 gallons per square foot, and that math shakes out to about 260 gallons of water during a 3-inch rain. So 55-gallon rain barrel on your shed ain't gonna work. Definitely not gonna work on your house. Okay? There's so much more water than a rain barrel can handle.
Swimming pool.
Yeah, totally. And then we're going to talk about this in just a second too, but a gallon of water weighs about 8.8 pounds. And so that same rain, you got over a ton of water coming off the roof of that shed in a 3-inch rain. And if you look at over the course of a year, so these are local counties, and this number is the 100-year mean. Mean is the middle number in 100 years, so 50 years. There was more than 58 inches of rain in Henderson County, and then for the other 50 years in this century, from 1901 to 2000, there was less than 58 inches. So that's a good number to just say we get about that much rain. in Henderson County. So let's say we take Henderson County and we get, remember, X is the number of inches of rain, put it through the formula. That comes out that 12 by 12 roof is going to have 5,061 gallons of rain in a year. That's 155 gallon rain barrels, right? And that is just to say that when we're thinking about where this water is going to go, I think people underappreciate how much water it is. So we always want to be oversizing our capacity. And this formula here, I'm saying that to people all the time. And so you could take your map and figure out the square footage of your roof, and you can figure this kind of stuff out to size your rain systems or your swales or whatever it is that you're going to use. And when we talk about the weight of water, again, Hendersonville, let's see, water weighs 8.8 pounds per gallon. And we know that from that shed, we're getting 5,000 gallons per year times 8.8 pounds. And that comes out to 25 1/3 tons. 50,000 pounds of water, which is the size, that's what a school bus loaded up with hippies and all the stuff they're taking to the festival weighs. So a fully loaded school bus is about 25 tons. So it's a lot of water, and that's important. So again, this, not gonna cut it. Even this, is that 500 gallon cistern, 1,000 gallon cistern? The thing about rainwater is that rainwater catchment is that we're not gonna catch it and hold it forever like a dragon on a hoard. We're just gonna release that water slowly, right? And so I just went to this class with all the permaculture elders, and they were just saying, George Brabant is a climate kind of scientist, and 1 degree of warmer atmosphere, what do you say, holds
11 something?
Yeah.
7.5 or so. I feel like it was 7.5 more.
Percent
Yeah.
of water in that warmer air.
Yeah, point is it's drastically steep.
Drastically steep, yeah. And so what happens is, over here we get a desert because that warmer air is taking all the water from here and then it goes over here and it dumps it. So our rain events are getting to be bigger and further apart. And so we don't get these gentle rains anymore. So if we're going to do this kind of system, we need to do that with the intention of kind of constantly emptying this at a slower rate. So you're just like capturing it all and then letting it go out slower. You're not holding it, you're just putting it through your system more slowly. And even then, at that point, this holds as much water as it holds, but we can store water in the earth way cheaper. So this is a swale and a berm like we were talking about before. This is a good example of it. The slope here runs this way. So they've taken out all the earth along this contour line. That's the swale, piled up on the berm. And so if this is 24 inches deep, and then they raise this up 24 inches, they got a 48-inch deep by 100-foot long by 4-foot wide thing. Now we're talking thousands of gallons of storage. And the idea for this is that water would get into that. Maybe it's there for a day or 2 or 3, and it just has to penetrate the soil before it can go anywhere else. And planting, you plant the trees into that berm, and that's what that would be for. Okay. And when we're talking about flooding, and I'm not talking about flooding like the river rose up and carried the house away flooding. I'm talking about on your land flooding. And there's 2 different kind of types of flooding. One is when your drainage or whatever gets overwhelmed. This water's moving, it's flooding at a high velocity, at a large volume, and it's in the drainage channel, or maybe it's still going in that direction, but it's bigger than that. And that's what's it's going to undercut your banks, it's going to deepen the channel in the middle of that stream, it's going to straighten it out, it's not have those meanders that makes water go slowly. And so that's kind of one that is a problem. And then there's another type of flooding where the water isn't moving very fast, but it won't go anywhere. It's not moving at all. It just builds up and builds up and builds up, and that's where that water, the weight of water can really become to be a problem too. So there's there's 2 different types of flooding. And so let's just talk about if your drainage gets overflowed, right? So this is the Gauley River. Anybody done the Gauley in West Virginia? Cowards, no. so this is Pillow Rock, and this is the Summersville Dam, and they don't do this anymore. It used to be epic. You like put in your raft like literally right here, and those are like shooting columns of water out at like 2,800 cubic feet of water per second, and that's like, I don't know, like 100 feet before it even hits the ground, and then you just like get in your little raft, and that first raft is class 5, and it's called initiation. But anyway, that's not about this talk at all. But my point is for this is that like the water is in this channel. The water's been crashing up against Pillow Rock forever and forever and forever, but it's being held back by this dam now. And so if that dam were to break and all that water that's is coming through this sluice gates at that rate, what if that dam just wasn't there anymore? Like, what would happen to that drainage? It would become completely overwhelmed, right? And so that's kind of what we're talking about, right? And just in case you didn't know, that's not a stock photo. That's me. 15 years old, first trip down the Gulf. Thank you.
Thank you.
Email me if you have any questions.
Okay.
Yeah, and then we all know like what happened when on the fjord of Arendelle when but Anna had to get the Earth Giants to break down the dam, and then the water came, but then Elsa came and saved the day on the water horse. So
Right.
that's permaculture. Okay.
So is the 3-year-old the excuse, or like,
It's a good
is that your backup?
Craig, look at me. You never seen Frozen, Craig?
I have some.
Okay, good. He was just acting cool. He was being tough. All right. So here's some strategies for flooding. The number one thing, if you don't remember anything else about water, is that the idea is to slow it, sink it, and spread it. Slow it, sink it, and spread it. This is the parking lot at this park in Travelers Rest. We were doing a craft show, and I was like, this is me taking you out of the matrix. You're never gonna stop seeing this stuff again. These trees are dying. First of all, they're planted too deep. Remember that. Secondly, look how poor the soil and this clay and awful is, and then look at how much pavement is around that, and the water. You see that little black little rectangle right there? There's like 8 of those all along that edge, and then there's a road on the other side. All the water in this entire giant parking lot flows into those little black drains and then goes out the road, and there's this huge retention pond, and there's all these rocks from the velocity of when it really rains. And again, remember that 0.6 gallons per square foot? Like, that's a lot of square footage. The answer to this kind of situation is that the water should be going into the earth here, not way over there, right? So this is what it does now, and this is what a parking lot could be, right? So permaculture design and practice, it's not just for farms and gardens, it's urban planning. It's recognizing that we live in an ecosystem. So the problem is the opportunity. The problem is there's all this pavement. The opportunity is the rainwater catchment that it actually can provide. I was out for a run the other day. This is in Laurel Park, and these 3 pictures all go together. It's hard to see it, so I took 3 pictures. That catches all the water coming down this road, and it catches a lot of water. And then now I'm standing on top of the thing, and there's this pipe that comes out right there. And then if you can see, there's like a big basin there with a drain cover on the bottom to collect sediment. And I guess once the water all goes down that drain, then it goes into another pipe and continues shooting down the mountain at some point. And we're just missing an opportunity to put it into the ground at every step of the way down the mountain. It's wasted energy. We have all that potential energy, the water up on the mountain. We could be diverting it to places that it needs to go or into the ground. But instead we just build these systems where we just catch it and we pipe it somewhere else, right? So slow it, sink it, and spread it. And ways that we can do that is that we plan these intentional overflows, So here's my garden. The slope runs this way. Here is a swale. Here is a berm. Here's the next swale. Here's a berm. And then my planned overflow is right through here. And it's just like a cut through the berm with some rocks in it just to help it not erode so fast. And that's no problem. I can build that back up if it erodes a little bit. But what happens is the water can only run, it's the swale is level. It can only go from here to there before it gets stopped again, right? So just stopping the water all the time. And sometimes the best time to go figure that out is when it's raining. So put on your rain boots and get your shovel, and while it's raining, go dig, and the water will show. It'll move. When it starts moving where you want it to be, then it's going downhill. So I do a lot of thinking and actively working on water while it's raining. And then again, this is in Travelers Rest too, at that There's like a taco shop and a brewery there, and there's a huge metal building here, and then this whole side of this metal building comes down to this black pipe. See that black pipe? And then it just goes straight out of there. And what we could do, I mean, just imagine if they dug a big pit, it doesn't have to be very deep at all. I mean, 6 inches deep over this whole area holds how many gallons of water to support how many trees, you know? And I could make that more fertile. You know, you give me 10 people and 10 shovels or 1 excavator, and we could do that in no time. So, live stakes, yeah, see,
Sorry,
no worries, send me an email. Live stakes are important. We have 2 weeks left. If you haven't live staked anything yet, go get something and stick it in the ground. Remember these 3 species: willow, silky dogwood, and elderberry. Those are going to be, you can put those anywhere in this region and you'll be doing everybody a service. And literally, as simple as it is you cut the living sticks like this in the dormant season, that's why we only have about 2 weeks left before they start breaking dormancy. They won't do this anymore. And then you put them in a bucket with water in them to keep them wet, keep the down end down, the up end up. And then you take a hammer like that and you drive some rebar into the ground and open up a little hole, and then you stick that in there, and then it'll root by itself. It has the hormones in it to root, and then it'll put off this new growth, and then next year you can cut off that new growth and you can keep sticking it. So if you were going to live stake an area to willows or to elderberry, it looks like that when you start. A few months later it looks like that. And here they've done it on a stream bank, which is a great place to do that. And here they've done this on the hillside, and this, if you drive those stakes in, those ones will reroot. But even some of these horizontal ones, they're like basket woven between the horizontals, or between the vertical ones, even some of these will reroot. Not all of them, but some of them will. And now you have like a living, rooted structure that's like actually holding soil behind it. And again, Craig, like in the woods, you know, slopes and stuff to build like beds and hold soil, that's a really great way to do that too. I encourage you to, if you haven't, has anybody never been on to their county GIS website? Oh, you got somebody to do it for you. Geographic Information System, and the county provides this. So whenever I start with a client, you know, we get the GIS of their house. Here's how I can measure the square footage of that roof, right? And there's also the topography lines are on here. There's not many on this, but this shows you the topography lines. It can show you some of the varied utilities. There's pictures, there's aerial imagery going back. Henderson County has like 2025, 24, 23, like back to the 80s, back to the 60s in black and white pictures. There's a layer on all of these that show the flood, historic flood plains, and this is Henderson County. So if your house is inside of any of these areas, it has flooded there before, so that's good to know. This is the landslide, the slope steepness map, and so this is LiDAR, and it's like radar elevation mapping, and so you can see the high spots and where, like, you know, the steep slopes. And here is this is kind of a closer up thing. These are the what are those? These are the debris flow pathways. So debris has flowed in events historically in those regions too. So there's lots of good stuff, and I'd be happy to show you more about that another time. And then again, too, just holistic soil health. Your soil, a living, vibrant soil microbiome is going to be more resilient to any kind of environmental fluctuation, whether it's drought or flooding or wind or pollutants or overgrazing or anything. So having, you know, really focusing on soil health is super important. In my soil, like it's you know, your healthy soil is my garden. But yeah, always be building soil. I guess that's the point why I put this on here. That like every leaf that falls on my land, all the compost, all the chicken waste, like I'm always trying to build the soil. It's my #1 priority. I grow soil before I grow plants. And if ever you see signs where the soil is disappearing or flattening or something, like that is where you're observing and interacting, that's a place to go back and adjust. If you're losing soil for any reason, that's not how nature operates. It doesn't consume soil. It uses it temporarily and then builds it back up again. And then the idea of microclimates. So, this room could be a different temperature than that room. This side of the room might be more sunny than that side of the room, right? Than where the air conditioners are. Same thing with your land. The sun rises in the east, moves through the southern sky in the northern hemisphere, and sets in the west. And so on this side, there's going to be more sun. On this side, there's going to be more shade. Those are different microclimates, right? We know this about mountainsides. Like, this is why the Pacific Northwest is very green, and then on the other side of the mountains, the deserts are very dry. And so what I'm trying to say, the reason I'm saying this about microclimates is that, like, if you have a really wet area in your yard, don't try to make that a dry area that you can then grow tomatoes in. Grow things that like wet soil in the wet areas. Grow things that like dry soil in the dry areas. Embrace the microclimates. Identify them and use them the way that it's easier to use the land the way the land wants to be made than try to force it into something that you want to do. So try to change your approach before you try to change the land to achieve a goal, right? And this picture is again, you can see way better on a computer, but the sun is shining through this tree, and in that shade there is frost, right? You can see that little white outline. So the frost is only in the shadow of that tree. And as that sun moved through the sky, it would melt on this side first. And so, whenever I see that kind of thing, that's where you can kind of identify a microclimate, right? Where the frost melts last, or where the frost melts first, or like that sort of thing. And paying attention to that, we are going to have a lot of new microclimates. So the reason I bring this up is because there was such a drastic change to all these environments, we're going to have a lot of new microclimates in places that you didn't expect to see them before. For instance, more sun is going to be used. Of a shady climate, cooler, less wind. Now we're going to be in sunnier, more wind, and that's not necessarily a bad thing, but it is something that we should pay attention to as we're designing and planning. So to identify and embrace microclimates. Oh, and in this box, inside of that cold frame, that's a microclimate inside of there. It's more humid and warmer and all that sort of thing. So use that to your advantage. And again, with the permaculture principles, use and value diversity. It's good to have lots of diverse microclimates because you can do different things in different years. Really hot year, your cooler areas might do better. Really cold year, your warmer areas might do better. Paying attention to microclimates. Okay, and then landslides. So that's the road that goes to my house. And yeah, this is it here. So this is Finley Cove Road in Henderson County. And what happened was, actually, I'm on the planning board, and we got a application for a new landscape design for this property here. And I said, wait a minute. And I'm going over and I look at it. And I go to the meeting, and they're building a house with a roof and a driveway and all that kind of stuff on that. And it is in this Finley Creek watershed. So again, my house is here. This is my land. This is my in-laws' land. And this is Finley Creek. And I said, what do we, I did the math like I just did for you, and I put it up on the screen so everybody can see it. I said, this is how many extra gallons of water, if the 100-year mean of Hendersonville is 60 inches, that this Finley Creek is going to have to drain now because there's an impervious house and driveway in this place. And so what's the plan for that? Do our rules allow for that to happen? Because this creek, when it came up, it crashed through this road, that's that, and then it crashed through this road, which is that, and then it crashed through this road, and it miraculously did not kill the people who live here. Like, there's just no one right there and right there. I mean, but there are people that live all in here. They had all been dead. And my point is, when we're like, the water has to go somewhere. And if it doesn't, then this is the kind of thing that's going to happen. And as I'm on the planning board and I'm in a lot of these meetings and stuff, there are a lot of people who's first of all, they don't care or know about this. They're not here this weekend. They're not at Organic Grower School. But they also just more houses is more tax base. They don't know, they don't understand that we have to have a capacity for where this water goes. And we know how it happens. Like, this is geology. This is there's no big mystery about how it happens. And we just need to recognize that like this is a very real concern in this region. I think a lot of people think, landslides, that's third world countries, it's like, down in like Peru or Guatemala or something, but like, that's not the case. So let's talk about how we can address some of those. The first thing is soil likes to be covered. I call it, soil likes to be modest, Soil ought only reveal itself when necessary. And so the best thing that you could have covering your soil is living roots. And the next best thing is dead but still intact roots in the ground, like a tree with a stump but the roots still on the ground. The next best thing is to have like dead organic material. That's your like, manures and compost and that sort of stuff. And then it's also good to have just like carbon rich stuff. So again, my house, these are the new terraces that I created. Remember those logs that I was showing you that make the terrace, this terrace and this terrace. And as soon as Megan can tell you, I was stressing out. I was like, I gotta get that soil covered, gotta get it seeded before I can cover it. And so now it's covered and it's happy. And this is what the top of my garden, remember, keep it high. Luckily my driveway is here and my garden is below. So this is just where mulch and stuff goes. I used to blow leaves and people would just blow them out of here, and I say capture them, just put a roll of fence around and make a circle, zip tie it together, fill it full of leaves, and that becomes lots of great compost. And then this isn't my picture from the internet, but that looks like a row of corn, and they're growing clover in between instead of just like spraying Roundup over the Roundup ready corn so that you don't get weeds in between. Choose your weeds. Nitrogen fixing clover is a great mulch, living mulch. And then, gang, I've now deputized you all to be propagation champions. Like, we just need so many plants. Just plant plants. So learn to propagate native plants, learn to identify native plants. Live staking is a great thing. Seeds, plant them, keep them in your car. Every time you drive by that guy's house, like, toss my moon, I don't care. Just plant native seeds everywhere. And then this is a pretty cool technique that I'm gonna start experimenting with more, but this is called air layering. Anybody done any of this? Cool. So you cut this, you take the cambium off and reveal the heartwood of a branch on a tree, and then put soil around it, and then put it in that like watertight, humid environment. Don't use clear plastic, use opaque plastic because it'll grow roots, and the roots like the dark, and that tree will do that. And then you can just, once it gets roots, you just cut it off at the bottom, plant it in the ground, and you have a new tree. And so you can get to a mature tree years faster, whether it's a fruit tree or any other kind of tree. You can get there way, way faster by doing this type of propagation technique than to try to grow it out from seed. And then also if you're like guerrilla gardening or trying to plant stuff in places just to slow water and hold soil, that's going to take a lot less like nurturing to get to grow than a seed will. So air layering is a great technique also. And then this is my house and the topo lines and all that. And this is the, some of the information you can get on that. So there's the contour lines, continental divide, elevations, water supply watersheds, wetlands inventory, it's like soil type. I have on the landslide mapping data, so down there at the bottom of my land it's pretty steep. There wasn't a landslide there though. But that's where the count, anyway, debris pathways, so there's your GIS, you should look at all that. And then terraforming, terra, like the earth, forming the earth intentionally, changing the earth. That's what me and Thomas were doing with the excavator and contour lines. We dig a big trench like that, and then pile up the earth on the downhill side, plant it to trees. Into that trench, I put all the like roots and sticks and logs and this other like woody debris, like a hugelkultur bed, kind of thing. And then those wood chips that were up at the top of the hill, then we'll fill in that to bring it back up to grade. So there's a berm, there's a trench, it's full of sticks and logs, and then I'll fill it all in with wood chips so it'll be like flat to walk on again. And then water just has to go. When it goes down this hill, it just goes straight into the swale and we'll water the trees passively and permanently. And then living willow. So this is a year for me for willow, so next time you see me, I might be like just dressed in willow clothing, and I've changed my name to willow, but black willow, Salix nigra is the native, really prolific common willow. And I think it's just about the most important plant that we can be using right now. And even if you're not like live staking it into stream banks right now, we still have 2 weeks left of live staking season-ish, maybe 4. And go cut some willow live stakes and bring them back to your house, and I'll teach you what to do with them next year. But you're gonna want them for this like coppice culture. Like, so just like we're talking about coppicing, here's me and my daughter, and we are weaving this fence together, right? So I just stuck those in the ground at angles, and I'm weaving them together and tying them together, and they will graft this and become one living homogeneous structure. And that can hold a lot of soil, a lot of water, and it's, I think, really beautiful. And yeah, and then the same idea that you just coppice it every year, but instead of coppicing just a stump, you'll just coppice, here they probably come across and cut, those off every year. So lots of things. I've seen beautiful domes. They've made this, like they call it the Willow Cathedral in this place in Germany. It's so beautiful. Willow's pretty cool. All right, I know we're almost, I'm gonna keep going real quick, these last few slides. And if you're growing crops in a garden, you should be growing as much habitat. So this is like a food forest, and it looks like a forest, but it's growing all this food, right? And here, as the forest ends, it's growing the food. So the more we create bird habitat and the birds eat the seeds, they carry them off, the more we're gonna be spreading native plants. So we can't spread native plants without native animals. They're part of the ecosystem, and we need to have habitat for those animals. Also, take care of yourself. Like, I realized that when my daughter was young, I was carrying her around, like, if I didn't start getting myself in shape, that I wouldn't be able to do this work. And so it's physical work, shoveling and digging and dragging stuff around and walking up and down. So if you're not taking care of your body and yourself, whatever it takes to do that, that's going to be an important part of the recovery as well, that we need to be healthy and able to do this work. And then also in public service. So as I said, I'm on the planning board for my town, and so our job is to make sure that people's development plans fit this unified development ordinance that that the planning board develops in coordination with the town council. So that's cool. If you can get on your planning board, I highly suggest that. It's really boring and it looks like this, but it's really important. And then Buncombe County's comprehensive plan for 2043 is coming up. How are we going to use the land in Buncombe County and make public comment? Like this guy, this Vietnam vet here at this Cleveland City Council meeting, he doesn't look happy, and he's expressing that to his elected representative. So even if you're just show face in the meetings and don't be afraid to make public comment.
Thank you.
You're welcome. This is the last look, guys. There's 2 more slides. Here we go. I think that we need to collaborate across parcel boundaries. Work with your neighbors. The ecosystem doesn't stop at the parcel boundary. And then next is you can't and you don't have to do it all. So if whatever you're passionate about, whether it's plant propagation or prescribed burns or whatever it is that you're into, go into that deeply. We don't need one person doing it perfectly. We need everybody doing it imperfectly together. And animal integrations are hugely important. So if you've been waiting for a nudge, be like, I really should get some chickens, do it. Get some chickens, learn to integrate animals in your system, and you're gonna have a healthier and more resilient system, and I'd be happy to help you design that system. I'm a coach. Check out my website, all the information is there. There's a flyer there, please take that. I'd be happy to help you design and learn all this. It's like a PDC, but it's a one-on-one, and your land is the classroom, and we'll learn permaculture by looking at your land. And I cannot say enough good stuff about OGS and how important and formative it was for me. So if this is your first time at the conference, please come back, please engage, please volunteer. I wasn't a teacher when I started, and I've learned enough to I feel really honored and humbled to be here to do that. So that's all I got, and I'll stick around for questions, and please take a flyer. Thank you so much.